I've talked about how to multiply index numbers, how to divide index number, how to relate with index number having a negative power, as well as when the power it has is 0. So we want to move ahead from that place. So, and we are going to solve so many examples in today's class. So example 1. Simplify the following. Number 1 there, 10 raised to the power minus 3. Number 2, 1 over 4 raised to the power minus 2. And number 3, x raised to the power 0 multiplied by x raised to the power 4 multiplied by x raised to the power minus 2. So, and solutions to all this. In number 1, what we have is 10 raised to the power minus 3. If you can recall very well, in our last discussion, I said it that it's abnormal for our base to always have what? A negative power. So, and once that happens, there is a solution to that. So what we ensure in that case is that we must make sure that what? The base exists as what? As a fractional number. The only condition whereby our base can have a negative power is when such a base is what? Is a fractional number. And it is possible at times that the number given to us is not a fractional number. Once it's not a fractional number, we force it to become a fractional number by re-expressing it as whatever number is given to us over 1. So this will now become 10 over 1, then everything raised to the power minus 3. So that is the first thing which we have to do. Then the next thing is, how do we get rid of the negative sign? So getting rid of the negative sign here means we are going to interchange the position of numerator as well as denominator. That is, this one will go up, this time will go down. That process of moving one here and moving the other here is what automatically removes the negative sign, and our result here is going to be 1 over 10 raised to power what? Raised to power 3. And by definition of what an index number is, we know what this expression here means is that what? This number inside the bracket should repeat itself 3 times. And that becomes 1 over 10 times 1 over 10 times 1 over 10. 1 times 1 times 1, that gives what? 1. 10 times 10, 100. 100 times 10, 1000. And our result here is going to be 1 over 1000. In number 2, what I have there is 1 over 4 raised to power minus 2. Remember I said it that it's not normal for what? Our base to have a negative power. But since it has a negative power now, then what must happen is that what? The base must be a fractional number. And let's go back and check the base which we have. So we can see the base exists as a fractional number, and now that it exists as a fractional number, eliminating the negative sign is very simple. What we are just going to do in this case is what? I will interchange the position of numerator as well as the denominator. So a mere interchanging of their position is what automatically removes the negative sign, and this now becomes 4 over 1 raised to power 2. Now, to conclude, our answer means we will interpret what we have here. So interpreting it means this element inside the bracket should be repeated this number of times. That is, we should repeat it twice. And that becomes 4 over 1 times 4 over 1. Then 4 times 4 here, 16. 1 times 1 is 1. And we know 16 divided by 1 will give 16. Now number 3. I have x raised to power 0 multiplied by x raised to power 4 multiplied by x raised to power minus 2. When we observe this question very well, we are going to see that this is a normal case. The power, though the power is 0, it has its own meaning, but one thing we see here is that this power is normal here. It is normal for us to have this type of power, but it is abnormal for us to have this type of power. So since it is not normal for me to have this type of power, this is the first thing I will have to adjust here. I will have to make it normal first. So making it normal means the base must be a fractional number. So solving it, so I will write x raised to power 0 multiplied by x raised to power 4 multiplied by x over 1 raised to power minus 2. Now that the base exists as a fractional number, it will now be very easy for us to eliminate the negative sign. So that becomes x raised to power 0 multiplied by x raised to power 4 multiplied by 1 over x raised to power 2. Now we want to complete this thing before we consider everything in general. So this is the same thing as saying x raised to power 0 multiplied by x raised to power 4 multiplied by, remember what this thing means. It means that what I have inside this bracket should be repeated 2 times. So and that becomes 1 over x times 1 over x. And I can as well, since this one it forms a fraction, this is a fraction, I can as well call this one fraction and this one fraction. So this can be like this, like this. So to continue, what is the meaning of x raised to power 0? We know anything that has the power of 0 automatically becomes 1. So this is like having 1 over 1 multiplied by, remember the meaning of x raised to power 4 means x to be repeated 4 times, and that is going to be x times x times x times x. So I can say everything as 1 over 1 multiplied by 1 over x multiplied by 1 over x. So what we now do is we compare numerator as well as the denominator and we cut. That is, we are going to divide where possible. So this x here can cancel the x here, and this x here can cancel the x here. What do we have left? What we have left is 1 times x times x times 1 times 1. In short, what we have left is this 1 times x times 1 times 1, everything over 1 times 1. And we know that will leave the result of what? X raised to power 2, because 2x, you know, every other thing multiplied by 1 we still give x raised to power 2. X occur in 2 places now, x raised to power 2 over 1, and finally our result is going to be what? X raised to power 2. So we are going to take the next example, and in my next example, that is example 2. Example 2. Simplify a raised to power minus 3 divided by a raised to power minus 5. So solution to this one. So the first step is to write the number a raised to power minus 3 divided by a raised to power minus 5. Now, when we look at this thing very well, we are going to see that this, in both cases, are abnormal cases, and we have to normalize it. How do we normalize it? That is by eliminating the negative sign. And for me to eliminate the negative sign, it means my base must be a fractional number, and now that is not a fractional number, we'll force it to becoming a fractional number by writing it as what? A over 1 raised to power minus 3. Then the same thing will happen here, a over 1 raised to power minus 5. So eliminating the negative sign here means I will interchange the position of numerator as well as the denominator. So this one becomes 1 over a raised to power 3 divided by 1 over a everything raised to power 5. And the next thing, or the next step is we are going to interpret this thing. You know, what we have here means 1 over a should be repeated 3 times. That is 1 over a multiplied by 1 over a multiplied by 1 over a divided by. So the same thing will happen here. We are going to repeat this thing, this element inside this bracket, this number of times, that is 5 times. That will be 1 over a times 1 over a times 1 over a times 1 over a times 1 over a. Now let us multiply everything. So when we multiply now, I will have 1 times 1 times 1. That gives 1 over a. So how many a do I have here? 3a. So a is repeated 3 times. Repetition will serve as our power. So that is a raised to power 3 divided by. So when I multiply all this, 1 times 1 times 1 times 1 times 1, we know that is going to give 1. And in the denominator here, what we have is a times a times a times a times a. We can see what happened there was that a was repeated 5 times. That is, the result of multiplying all this will give a raised to power 5. And from the primary school division, we were told then that division at times used to change to what? Multiplication. So we are going to convert this our division to times. So that's going to be 1 over a raised to power 3 times. And remember, whenever division changes to times, what happened is that both numerator and denominator will also change their position. So that will be a raised to power 5 over 1. So when this is multiplied, we are going to have a raised to power 5 over a raised to power what? 3. So getting our answer means we will split this one into a smallest form as well as this one. So a raised to power 5 is the same thing as saying a times a times a times a times a. Everything here over a times a times a. And we are going to divide where possible. You know, this will cancel this, this will cancel this, this will cancel this. So the result we have now is what? A being repeated 2 times. And remember, the reward repetition here describes the power. So our answer here is now going to be a raised to power 2, or what we can simply call a squared. So we also move over to the next example, which is example 3 rather. Example 3. So I think it will be better for me I also move over to the next page of my book here. Now example 3. Simplify. Two a raised to power minus 1, number 1. 2 a raised to power minus 1 multiplied by 3a squared. Number 2. 2a raised to power minus 1 times 3a squared. Number 3. 2a raised to power minus 1 times 3a squared. So those are the last 3 questions we want to take on our indices. So solution. In number 1, what we have here is 2a raised to power minus 1 times 3a squared. So when we look at this question very well, we can see that there is a case of abnormality. So, and that abnormality will have to what? to be make normal. So what I have here is 2a raised to the power minus 1. So when I have a letter following number immediately, or when our base has a coefficient, it is better we separate coefficient as well as the base with what? Multiplication sign. So that first of all gives 2 times a raised to the power minus 1. Then times, when we look at this one very well, we can see what it means is that the element inside this bracket should be repeated twice. So which means 3a times 3a. So and this becomes, so remember, so this is going to be 2 times, here is a raised to the power minus 1, the power here is negative, it is abnormal. So for it to be normal, the first thing is that the base has to be what? A fractional number. So that becomes a over 1 raised to the power minus 1 times, so in this case, it is advisable I split it, the coefficient as well as the base which I have here, 3 times a times 3 times a. And that can as well be written as 2 times, for me to eliminate the negative sign now means 1 will come up and a will go down here. Everything now raised to the power 1 multiplied by 3 multiplied by a multiplied by 3 multiplied by a. So and that will give 2 times. So this bracket here means what I have here should be written once or should be repeated one time. So that will become 1 over a times 3 times a times 3 times a. But we can see that this one is in fractional form while the rest are in whole form. We may not reason it that way. Now the next way of reasoning is this one should be able to divide one of the a which I have here. So what I will do here is I will use this a to divide this a, or I will allow this a to cut this a. So what I now have left is what? 2 times 1 times 3 times 3 times a. And remember, I said it previously that numbers will multiply number and letters will multiply letters in case whereby we have more. So 2 times 1 here gives 2. Now 2 times 3 here 6. 6 times 3 here is 18. So we have 18 times a, which is equal to 18a. So our answer to number 1 is 18a. In number 2, what we have there is 2a, everything raised to the power minus 1 multiplied by 3a squared. Now I want us to note some differences between the first question as well as the second question. In the first question, we are going to observe that only this a has the negative power. So, and it is the only one we must what? Readjust to fractional form. But when we observe this situation now, it is everything here that has a negative power, and that is the essence of brackets. The bracket group them that all the elements inside main has this negative power. So it is everything inside this bracket we must make to have what? To occur as a fractional number. So to eliminating our negative sign means we need some steps. So the first step here is to allow our base to what? Well, to occur as a fractional number, and that is going to be what? 2a over 1. So everything here raised to the power minus 1 multiplied by 3 times a times a. So this is now going to be 1 over 2a raised to the power 1 times 3 times a times a. So remember the meaning of this. This thing should be written once. That is 1 over 2a times 3 times a times a. And that is going to be what? 1 over 2 times a times 3 times a. Let us divide where possible. Now there is additional a. We divide where possible. We can see this a, we cancel this a, and the result which we are going to have is 1 times 3 times a, and that's going to be 3a over 2. So our result here is 3a over 2, or what we can as well write as 1.5 a or 1.5 a, or let's leave the answer as 3a over 2. That's the case of number 2. We will now go and solve the last question, which is number 3 there. So in number 3, what I have is 2a raised to the power minus 1 multiplied by 3a squared. Multiplied by 3a squared. So solving this one means that I have to correct this negative power which I have here. And remember, it is only this a that carries a negative power. It's not both. So it's only this a that have to what? Be rewritten as a fractional number. So to solve that is to say 2 times a raised to the power minus 1 times 3a raised to the power 2. So that means 2 times a over 1 raised to the power minus 1 times 3 times a times a. So I can do it that way, which becomes 2 times 1 over a raised to the power 1. Now we can see the negative sign has disappeared due to the fact that what? We have changed the position of both the numerator and the denominator here. So multiply by 3 times a times a, and that gives 2 times, hope you remember the meaning of this, 1 over a raised to the power 1 means 1 over a should be written just once, times 3 times a times a, and the rest is we cut where possible, and we can see that this will cancel this. So the result that now gives is 2 times 1 times 3 times a, which finally gives what? 6a, and that is the solution to that. So with this, we have come to the end of what? Our session or the class on the laws of indices.